Hello everyone, welcome back to Module 2, Lesson 4. We are still talking about diagonal scale. So from the last question we solved, we have another type. They can give you questions in different ways. So you need to know how to interpret these questions as they are given. So the other one said a diagonal scale of RF 3 in 100. Now this question is saying an area of 144 square centimeters on a map represents an area of 36 square kilometers on the field. Find the RF of this scale for this map and draw a diagonal scale to show kilometers, hectometers, and decameters to measure up to 10 kilometers. Indicate on the scale a distance of 7.56 kilometers. So we have another type of question here which we are going to be solving. Here you see, like I said, the three parameters that must be present for your scale equation to be complete is your RF, the unit, and the length. So here our RF was not given. The units that were given were kilometer, hectometer, and decameter. And they gave us a maximum length of 10 kilometers. So now we cannot solve this question directly like this because our RF is not given. So we have to calculate for RF. Now, what is the formula for RF? The formula for RF says RF is equals to distance on the drawing over actual distance. So that is the formula for RF. Now, in this case, they are telling us an area of 144 centimeters square representing an area of 36 kilometer square. So what do we do with this case? You notice that here we have the unit squared. So what we need to do, we need to eliminate these squares and bring them down to a plain unit. So if we take the solution to this, we now take the square root of both sides. So if you take the square root of both sides, you're going to have 144 cm squared is equals to 36 km squared. So this is how you are going to have this from your idea of solid in mathematics. You're going to see something like this. So this can also be broken down like this. We also have 36 dot km square. So this will cancel this will cancel this. Square root of 144 will give you 12. So we now have 12 cm here. Square 36 will give us 6. So we now have 6 kilometer here. So we've now succeeded in bringing this thing down to a plain unit. So after this, the next thing we are going to consider is converting this kilometer down to centimeters. And we know that 100,000 centimeters is equals to 1 kilometer. So therefore 6 kilometer will be equals to 6 times 100,000 centimeter, which is going to give us 600,000 centimeters. So if you look at our formula here, RF is saying distance on the drawing over actual distance. So centimeter, which is the smaller unit, is distance on the drawing. The actual distance is 36 kilometer. So we are now going to say, therefore, our RF is equals to 12 centimeter divided by 600,000 centimeter. So this centimeter will cancel this centimeter. 12 in itself here is 1. 12 in 60 is 5. So what we are going to be getting our RF is 1 all over 50,000. So that is the RF for this question. So now we are going to be looking for our length of scale, which is LOS. So our LOS is equals to RF times maximum length. Now, our maximum length here is equals to 10 kilometer. So if you come here, we say 100,000 centimeters is equals to 1 kilometer. So we are going to convert this our 10 kilometer to centimeter. So which we are going to be having 10 times 100,000 centimeter, which is going to give us 1, 2, 3, 4, 5, 6. So we now have 1 million centimeter. So therefore, LOS is equals to 1 over 50,000 times 1 million centimeter. So 1, 2, 3, 4 will be cancelled by 1, 2, 3, 4. So we now have 5 in itself, 1, 5 in 100, 20. So our LOS is 20 cm. So once we've gotten our 20 cm, you now come back to normal drawing of your scale. It's going to give us a length of 20 centimeter. The first line you're going to be drawing is a line of 20 centimeter. When you draw this line, you now produce your rectangle. I normally use 3 centimeters for my rectangle. Here, this other side. I also use 3 centimeters. Then note this dimension can vary. You can use 2 centimeters, you can use 3, you can use 4 centimeters to produce your rectangle. It's just your decision to make. So now after this, I'm going to draw my diagonal line. Just like we saw, every other thing we did in diagonal scale will repeat itself here. So now we're going to divide this scale into 10 equal half because our maximum length is 10 kilometers, sorry. Just like we saw in the other example. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you number here 1, 2, 3, 4, 5, 6 up to 10. So 10 is the last number. You now link 10 to this point. Now you take your set square and produce parallel lines same as that of line 10, like this. You move it to 9. And draw. We are going to repeat this exercise until you get to 1. Make sure all your lines are parallel. So when you've done this, you're also going to come here and produce vertical lines here. Just like we saw in the other example, we repeat the same process here. To now have this, remember to renumber these points, just like we saw in the other example, starting from 0. So you come here and produce this other line again, just like what we have in the other example, divide it into 10. Number. So you link 10 to 0, like I said in the previous example. The process is just the same. The only difference is the parameter to solve to get your length of scale. So repeat the same process. So now make sure you produce these vertical lines. So here again, repeat the same process of getting a diagonal line and divide it into 10 using smaller radius. Number. And use your set square. So you continue here, making sure you produce the horizontal lines. And see the way I position my set square and my ruler. Make sure I have perfect horizontal lines. So you produce your graph like points there. Now number this 1, 2, up to the last one. 9 and 0. Let's start again here. 1, 2, 3, 4. Right, 0. So now they asked us to show a distance of 7.56 on the scale. So 7.56. This 7 is kilometers. This 5 is hectometers. And this 6 is decameters. So on the scale, this is the kilometer section, this is hectometer section, and this is decameter section. So we're going to be showing our numbers now. 7 to count 1, 2, 3, 4, 5, 6, 7. Put this your line. Now it's 7.56. So you come here. 1, 2, 3, 4, 5. Between 5 and 6, you're going to use that point. Draw, just like we did in the previous example, a diagonal line from the bottom point of 5 to the topmost point of 6. Then we are now going to come to the decameter section and now count 6. So you now have 1, 2, 3, 4, 5, and 6. So if you trace that 6 where it meets that line, it's meeting it here. So that is the point of intersection. That is the point where you have 7.56. So you're going to produce a vertical line coming out from there. You see, like this. Now link both of them. No. Write this. So you come here, indicate the unit. Here is for hectometer. And this last section is for decameters. So remember to indicate your RF each time you produce the scale diagram. So this is the same, just like the other example we have, but the difference was just the parameters. So once you are given a scale equation where you are not given the RF directly to produce your scale, calculate using this formula distance on the drawing over actual distance. So that's just the way you can see your scale equations. Make sure you like, share, and subscribe to this channel for more notification.